Alright, welcome back. So, we have our first 3 points to the left of our, ooh, that was weird, vertical asymptote. But now we have to find 3 points to the right. So, if our asymptote is at 6, we want to find our point at 7, 8, and 9. So that'll give us the point at 7, that is 7, 1. 8 is 8, negative 1. And 9 is 9, comma, negative 1.7, and that's fine with me. So let's plot these points now. So we have 5, negative 7. We have 4, negative 5. And 3, negative 4.3. And then on the right we have 7, 1. 8, negative 1, and 9, negative 1.7. So our graph is going to look something like this. And make sure, one of the most important things is your graph cannot touch your vertical asymptotes, okay? So if you need to make a note to yourself, then do that, but your graph should come really close to your vertical and horizontal asymptotes, but it's never going to touch it, okay? Well, I guess it could, but as we draw it, these asymptotes are just meant to guide your graph, okay? So as you draw them, don't have your graph cross your asymptote, okay? So this is all we need to do for our general rational functions, okay? So let's flip the page over to look at another form of our hyperbolas. Okay, so rational functions in the form of y equals ax plus b over cx plus d are also hyperbolas. Okay, so this is just a little bit more complex. And in this situation, the vertical asymptote occurs at the x value that makes the denominator 0. So to find that, we would set our denominator, which is cx plus d, we would set that equal to 0. Okay, and whatever value we get for x, that would be our vertical asymptote. And so if we were to do that, we would get cx equals negative d. So x is going to be opposite of d over c. That's just the generic, if you were to plug in these values, that's what you would get for your vertical asymptote. And our horizontal asymptote is the line y equals a over c. So if you notice a and c, those are our coefficients that are in front of our x there. So that's where that comes from. Alright, so if we are looking at number 2, this equation x minus 2 over 3x plus 3, looking for a vertical asymptote, remember that occurs when your x value has your denominator, or the x value that makes the denominator 0. So we set our denominator equal to 0, so we'll have 3x plus 3, set that equal to 0. Subtract our 3 over, 3x equals negative 3. That'll give us an x value of negative 1. Then to find our horizontal asymptote, that's just our coefficients, a and c. And in this case, there's no number multiplied by the x, so we just put a 1 there. So that would give us our horizontal asymptote as 1 over 3, or 1/3. And just like before, our domain is our x values. So we have to say, what x values can we not have? Well, it's going to be, we can have any x value, but since we have a vertical asymptote, we cannot have an x be negative 1. And for our range, the same thing, we can have all real numbers, but we can't have a y of 1/3 because we have an asymptote there as well. So what I want you to do from here is graph your asymptotes, plug this into your calculator, and find 3 points to the left of the vertical asymptote and 3 points to the right of the vertical asymptote, and graph it on here and see how you do. Okay? So pause the video and try graphing this on your own. Alright, so this is what your graph should look like. If you did not get this as your graph, that is probably because you did not put parentheses there on your numerator and your denominator. So if you need to make a note to yourself to do that, please, please do. Do not forget your parentheses and your numerator and denominator, because you're not going to get the correct graph if you do not put those in. Okay? So once you do that, you find your 3 points and connect them, and remember to not have your graph cross your asymptotes, and you should be good. Okay, so let's scroll down or look down at our real world scenario. Okay, so we're going to take what we've learned and apply it to our life. So you and your friends are sponsoring a dinner. The cost of catering the dinner is $9.95 per person plus an $18 delivery charge. Okay, so write a model that gives the average cost per person. So we want an average cost per person and given this information. So we're going to have two variables. One, well, I'll just use y and x. So y, that's going to be our average cost. And x, we have to say, well, what is our cost dependent on? Well, it's $9.95 per person. So our x is going to be the number of people. Okay, so how much it costs depends on how many people come. So from there we have to say, okay, so we know we're going to have y equals, and if we know it's $9.95 per person, that means if we multiplied x by 9.95, that would get us the cost total with all the people who came, so 9.95x. And we know on top of that, no matter how many people come, we're going to have an $18 delivery charge, so that's plus 18. And since we want the average cost per person, we would divide this whole thing by how many people come, x. Okay, so if we just wanted the total cost, it would be just the numerator here, but we want the average cost, so we're dividing this by x. Okay, so if we were looking at part B, so sketch the graph of the model and use it to estimate the number of people needed to lower the cost to $11. I want you to take a second and plug this into your calculator and sketch the graph. So our sketch should look something like this. It doesn't have to be too fancy. So if we want to use this graph to estimate the number of people needed, so remember, number of people, that's our x. That's our x. To lower the cost to $11, this $11, that is our y value. Okay, so what that means is when our y is $11, what is our x value going to be? So we plug in 11 for y, so we get 9.95x plus 18 all over x. So let's solve for our x. We multiply both sides by x to cancel out the x in our denominator. So we should get 11x equals 9.95x plus 18. We subtract over 9.95 and we get 1.05x equals 18. So divide both sides. We should get x as 17.14, roughly. Should be squigglies. So if x is a number of people, and we get 17.14, if we want to make that to be a whole person, we're going to round down to make it just be 17 people, because we can't have 0.14 of a person. So for C, describe what happens to the average cost per person as the number increases. So as our x value increases, what happens to our average cost per person? So what happens to our y? So this is just like our n behavior. We've seen this before. That's essentially what it is asking. What is our n behavior? Okay, so then looking at this, what happens as the number increases? So as our x value increases, what's happening to our y value? So as you can see, as our x gets bigger, our y value gets smaller. So that means our average cost gets lower. And as you can see, there is a asymptote here because it levels off. So if we would have sketched that in, that would have been okay. But so we have this asymptote. So it approaches, and we have an asymptote. That means it approaches an average cost of whatever our horizontal asymptote is, which in this case it's our $9.95 per person. But we knew that because our horizontal asymptote, I'm going to write a little note down here, our horizontal asymptote is y equals 9.95. Because if we're looking, remember horizontal asymptote is our c over d, and that's 9.95 over, or sorry, a over c. So that's our 9.95 divided by 1. So since this is our horizontal asymptote, that means it approaches an average cost of $9.95 per person. So that would be our end behavior. Okay, so it's never going to reach this cost, but it'll get pretty darn close. Okay, so this is it for our video. I know it was a little bit long, but hopefully it made sense. If you have any questions, please bring it to class.